22, live again. So where were we previously? We were doing some engineering mathematics. I think we were stuck at that one graph question, the one about the two coloring problem. We did this one. Yeah, this one. We are trying to comprehend this question over here. Yeah. Yep, I remember it pretty correctly. So yeah, I was thinking like this actually. Name mathematics, and I'm pretty sure I renamed it as mathematics. Yes, digital logic. Dude, the heck. Yeah. So making this as sections consumes less of the brain overhead. Yes. Programming and this algorithms, theory of computation, compiler design, operating systems. Okay, let's rename it as COA, CM. That's it. How to rename this notebook? I have no idea, but yeah, it should not be mattering anyways. Okay, we did enough of everything here to be honest. 14, 4, 20, 26. Okay. Is it is it showing everything? Yeah, it is showing everything. So our plan is like this. We will do 1 hour of mathematics, and then we will change the subject, and we will do that until 12, 9, 10, 11, 12. So there are going to be 4 streams of this in total. If I can endure until then. So what he is trying to say here is smallest vertex cover size k is equals to 3. So a graph is given to us, and vertex cover of G is V dash is a subset of V such that U comma V belongs to E, U belongs to V dash, or V belongs to V dash for all U comma V. K is size of smallest vertex cover if the vertex has k plus 1 degree, then vertex U, let's say, should always be included, because if it is excluded, size of vertex cover won't be k. Example, the central vertex alone is vertex cover for graph. Let's say k is equals to 3, then if central vertex is excluded into every other vertex need to be included for vertex cover. So k is equals to 3 is not satisfied. The vertex V is on the path length k plus 1, k is equals to 3. No compulsion of any vertex here. Similarly, for cycle, click of size 4, k is equals to 4, No compulsion. Okay. Let's say this edge is equal to 1, 2, 3. It is covered. Let's say this edge is equal and then this and then these are covered. And this is included. For black needs k is equal to 3 for vertex cover. This is what I have understood actually. Yes, it is a difficult question if you have not understood what the question is trying to ask you in the first place. But still, here undirected weighted. Okay, undirected, unweighted simple graph is said to be two colorable if there exists a function. See, where x belongs to 0 to 1 such that u comma v belongs to e and c of u is not equals to c of v. Two colorable. There is actually some theory regarding this. If G is two colorable, then G may contain cycles of odd length. An optimal algorithm. It is actually not supposed to be a part of discrete maths, but it is a part of algorithms. If a graph has an odd cycle, it is impossible to color it with only two colorables with the two edges and vertices ending up in the same color. For example, this is an odd cycle, and if you put it R and if you put it B, you can't put it neither R or B, neither R nor B. So odd cycle is false. So if you put this R, if you put this B, if you put this R, if you put this B, yes, even cycle may exist. An optimal to check if graph is two colorable means bipartite. You can use standard graph traversal algorithm, BFS or DFS works. How it works, I don't know. So if a graph is First color. This is different. You use BFS for checking. Assign a color to a vertex. Then other color to on its neighbors. Then the first color to their neighbors. This is basic understanding. For example, if you consider a graph something like this, right? If you make it R, you will make it BB, then you will make it R again, and you will make it R, you will make it R. It contains odd cycle, so no bipartiteness. Okay, makes sense. Wow. O of P plus E. This honestly makes sense, to be honest. Let G be an undirected graph which is a path on 8 vertices. The number of matchings in G is what is matching. The number of matchings on path graph is follows the Fibonacci sequence. What is matching and why? What is matching in an undirected graph and why does it follow Fibonacci sequence? Matching is a set of edges such that no two edges share a common vertex. Each vertex can be used at most once. Okay. Matching it is honestly making a lot of sense now. To complete this, alright. So the thing is, I have come to a conclusion that is when you are like stressed out, take 20 deep breaths. Right. Why does deep breathing reduces stress when studying a lot? Activating the parasympathetic nervous system, depressing reduces. Okay, this is responsible for body's okay, works out. Breathe air and drink water. Right, that's it. Hmm. I'm feeling much better already, to be honest. So, what is matching again? Matching a set of edges such that no two edges share a common vertex. Matching a path of length, a path of n vertices has Fibonacci n possible matchings y 0, 1, 1, 2, 3. Okay, empty matching is always allowed. Okay, this is base case. These are recursive cases. Okay. So we got five things here, namely A, B, sorry. So you are considering the JB. Now you are leaving the HBC. You are considering the CD. Similarly, uh, you are considering the HBC. And, 4, 5. That's it. So no perfect matching. Every every vertex needed to be included. Okay. This honestly makes some sense. 26 minutes. It is a random variable that takes from numbers from 1 to 8. Probability of x is equal to 1. Okay. Expectation sigma I is equal to 1 to n p of xi into xi. 1 into 1 by 6 plus 2 into 1 by 6 plus 5 into 1 by 6 plus 7 into 1 by 6 plus 3 into 1 by 12 plus 4 into 1 by 12 plus 6 into 1 by 12 plus 8 into 1 by 12 1 by 6 plus 1 by 3 plus 5 by 6 plus 7 by 6 plus 1 by 4 plus 1 by 3 plus 1 by 2 plus 2 by 3 4 alright 4 6 12 would be the LCM, right? That is 2 plus 4 plus 2, right? 2 5 is a 10, and that is 2, 7 2 is a 14, 3 plus 4 plus 6 plus 4 into 4 2s are 8. So if you do this, 2 plus 4 is 6, 16, 16 plus 14, 30, 33, 37, 37 plus 6, that is 43. 43 plus 8, 51 by 12. That is going to be, I'm going to do it without cashier. 12 fours are 48. And you got a 3. Right. 12 twos are 24. And you got a 6. 4.25 is going to be your answer. Mhm. The bases are in 6 and 12. By reducing them and LCM them again. Nice, actually. Because time matters in this competitive exam, and that is actually a pretty good approach. Yeah, so there are people over there that did a lot more math than me. So, yeah. Okay, two balls are drawn at random from the end, one after the another without replacement. What is the probability that the second ball drawn is white given the first ball drawn is black? 10 balls out of which 4 W and 6 black. This is conditional probability, right? P of E1 given E2, where E2 is equals to the first ball, black. E1 is equals to second ball white. Probability of E2 is first ball being black is 6 by 10. This is P of E2. These are not independent. Mean independent, but prob changes. Right, so 6 by 10, and you will have only 9 balls over there, out of which 4 are white, 4 by 9, because without replacement, that is 24 by 90. That is a probability into 10 by 6. 9, 24 by 9, 6 are 54. If you like cancel some things out of here, 2, 12, 27, 3 fours are 12, 3 nines are 27. B is going to be the answer. Okay, okay, we did it. So seems like this is paying off. So these are everything that we have already done. I feel like I have already done these two questions. I have done that question, and yes, I have done this question as well. And one, yeah, let's just check these questions once again before moving on, because it is math. K and be a complete graph of n vertices. K and is a complete graph. There exist multiple that is that is good enough of a space to you. Yeah, I think so. How many minutes are we down? Okay, we still got 35 minutes. The Jacquard ratio, okay. We have done the Jacquard ratio already, but nobody actually answered that one. It was given in like a text format instead of a formula for us. We have already done this one. We have already done this one as well. Okay, memory based in the okay, okay, memory based in the sense I got it now. Okay, I have honestly understood. So they came out of the exam hall and they try to recreate the question that they have seen. Okay, that is great. I consider myself that I completed engineering mathematics along with the discrete mathematics, and now we will jump into algorithms. What's the date today? 14 of 4 2026. They have not updated it to 2026 yet. Why do we have so many questions of algorithms? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That works out. Consider the following function. Which one of the following list of functions in asymptotic growth? Maybe can you brute force it? I assume it to be based on log of n factorial 2 to the power of log n. Let's do n is equals to 3, n is equals to 5, n is equals to 10. And let's see the values, right? Cube root of 3, yep, here. So 3, log 3. 3 factorial is 3 to the 6, right? So log 6, that is 0.778, and 2 to the power of log n. So that is 3, and you have a log, and you have a 2 to the power of 0.477. Similarly, if you do that for 5 cube root of 5, that is 1.709. I don't know what I'm doing. Right. 5 log 0.6989. Okay. 5 factorial is 5 4s are 20, 23s are 60, 62s are. Okay, wait. 2.079. 2 to the power of 5 log. Asymptotically, nobody has time to watch a almost 3 hour session to understand what's going on. So n factorial is approximation to n power n. No, not at all, right? 10 factorial and 10 power 10 are two very different things. We have a factorial 36,000. Two very different things. Two. Stirling approximation intuition. Okay. Mm. So this is a one more question. I say, which of the following can be recurrence relations corresponding to an algorithm of complexity O? Hmm. Recurrence relation corresponding to an algorithm. Yes, being very precise is important. So T of n is equals to T of n minus 1 plus 1 here growing by 1. Okay. So of one work at each step and there are n steps, okay. By master theorem. Okay, since it is master theorem, he did not like. Mhm. See, that's why now this 55 minutes already, and we have learned a lot. Mhm. Mhm. Okay. Not too bad. Yeah, let me just eat the eggs and drink some water before. You got it, man. So, T of n is equals to 2tn by 2 plus n divided into two subproblems size n by 2 do n work at current level. Level 0 work n. Level 1 two problems of n by 2 work is equals to n. Level 2 four problems of n by 4 work. So n levels with n work each. T of n is equals to ATn by B plus f of n. A is equals to number of subproblems. B is equals to shrink factor. F of n is equals to okay. work per level increases downwards. So, ooch. Hmm. Yeah, you will. Yeah, you will learn this master theorem. Anyways, right? Yeah, is increasing linearly. So n work p 1 work n levels 1 work. 2 subproblems of n by 2 work. Here, something like that. Yeah, your intuition is correct only. Two nodes, 1 work, 2 work, 4 work, log n. How did he get that? Okay. Something recurrence tree. If you truly understood recurrence tree method. Okay, so that thing checks out. So we got set to 20. Hash function came out and the collisions are resolved by chaining on. So to the length of the longest chain is that makes a lot of sense. H of k is equals to k mod 9, right? We got 5 in the 5. So 9 3 is a 27, that is 1, and 9 2s are 18, that is 1 again, right? And 9, right? You got a 6, 9 3 or 9 2s are 18, that is going to be another 8, and 9 3s are 27, that is going to be another 6, 9 1s are 9, that is going to be another 4, 9 1s are 9, that is going to be another 8, yeah, and another 1. The length of longest chain is 1 is longest chain length is 3. Not the mode value, but length of longest chain. Okay, that makes a lot of sense. Consider an array merge sort algorithm, increasing order, 7 merge operations. The merge operation on sorted array, left and sorted right array, void if the output. Okay, I have understood. 10 7 8 9 10 41 35 25 31. 10 7 8 9 10 41 35 25 31. 10 7 8 9 10 41 35 25 31. Three, if I'm not wrong. Got it. At least we are having an alright comprehension. We can see the progress. We would build for this man. GBA weighted directed a cyclic graph with images and then vertices given G and a source vertex S and J, which are the following options gives the worst cases time complexity of the fastest algorithm to find the length of the shortest path from S to R vertices that are reachable. Worst case worst case of fastest algorithm for finding the R pair shortest path. What algorithm do you know for R pair shortest path? Source CLRS. This section will introduce one further restriction on weighted directive of the cycle. We are concerned with weighted DAGs. Shortest paths are always well defined in a DAG since if there are no negative weight. If the edge of a weighted DAG or matched along with the topological zone. Okay, why is this guy bragging that he reads the CLRS? Okay, like a waterfall, not a dimension. One second. Cyclic. Come on, something like that. Yes, we are here. For shortest answers. Graph is a system of states and connections. Okay. Okay. Ouch. I will read this once, and if I got any questions, I will ask it once again. 1 hour 28 minutes. Yeah, since we are in the beginning stage of understanding, it takes some time, but it is alright. Yeah, let me drink some water. Mm. Yeah, so BFS is unweighted, neighbors recursively. DFS explore as deep as possible and then backtrack to apology diagonally for like directly cycling graph. Need to understand this dependencies and what are DFS and cons algorithm method. Dijkstra's. And what else we got? So I got a few doubts. Firstly, you need to explain the topological sort in more detail since I have not literally studied it once, and what are the dependencies. And so topological sort is better than Dijkstra's algorithm in every case, or are we talking in only a particular case? And Bellman-Ford algorithm is for finding the single shortest path, right? And which is better, like is topological sort better than the Bellman-Ford algorithm? And Floyd-Warshall is the only algorithm that you have mentioned for all pair shortest path, right? I just need a clear explanation. That's it. A linear ordering of vertices such that if there is an edge u to v, then u comes before v. U just bars. Okay. Okay. Alright. You just need to study. There is no other way. Alright. Let's write the answers. I mean, this is us learning theory, and the theory learning is very important. So it's been nothing more than like 1.5 hours. Hmm. So how many problems have we like done? Let's check. It's been like 1 hour 30 minutes, right? And we took our time. We did not rush. That's for sure. So one, two, three, four, 5 questions here, and 5 questions here, and then engineering mathematics, right? We started from the vertex cover, if I'm not wrong. Yes. So one, two, three, four, five. That's it. We did only 10 questions until now in like wow, 1.5 hours. But we are learning theory, so it is not bad. Anyways, topological sort is a linear ordering of vertices such that u2v uh, for u2v and u comes before v comes algorithm do ordering for vertices whose integrate is equals to 0 because they do not require any prerequisites. Only works for DAG, Dijkstra's SSSP with cycles, right? Bellman Ford Negative attributes. Floyd Marshall. APSP. That's it. So A is going to be our answer. We did a whole lot of analysis for this one because it is important. An array of integers of size and the indices here and from 1 to n, an algorithm is said to be designed to check whether A satisfies the condition below. Okay, for all I comma j belongs to 1 to n minus 1 such that I greater than j, a of I by a plus 1 minus a of I is greater than. Okay. Which one of the following gives the worst time complexity for the fastest algorithm that can be designed for this problem? I greater than j, a of I plus 1 minus a of I is greater than a of j plus 1 minus a of j. Okay, I need to firstly get an intuition of what this program is, like what this thing is trying to do in the first place. So let's say wait, it is not a matrix. Let's say I is this one, right? A of I plus 1 minus a of I. Okay. Okay, wait, I greater than j. That means for no check, for I is equals to here, check every pair before. So for n values of i's, you need to okay. That is a very great question. I have honestly understood the question after looking at the answer. Yeah. Okay. 229. Make me less scared of dynamic programming. Mm. Are we filling the debate table in the correct order? Find a table where each cell depends upon previous cells. Okay. The question I think does not is not as difficult as they have portrayed it to be. I think. Okay. Yeah, there are people with humor. So we are here, right? Do these algorithms compute the DP table in a valid order? We have a DP table. Each cell depends on top, left. When we compute the table, we understand today grid access like TFIJ dependency. If T of I j is equal to f of T of I minus 1 j, T of I comma j minus 1, you must compute those first. Loop order matters. Different loop orders is equal to different computation order. Okay. Okay. The recursive formulation. T of I j is equals to 2Ti minus 1j plus 3Ti minus 1. So you need above cell to be calculated and the left cell to be calculated. Example T of 3 4, you need T of 2 4 and T of 3 3. Mm, right. For every row, for every column, calculate 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. Works. Alright. That is an okay. 3, okay. So 0, 0, 0, 1, 0, 2. All of these are done already. 1, 0, 2, 0, 3, 0. Right. So 1 comma 1, 1 comma 2, 2 comma 1. Okay. And for 4, what you do is 1 plus 3, 2 plus 2, 3 plus 1. 0 comma 3. So 1 plus 3, 2 plus 2, 3 plus 1. Yeah, working. Dynamic programming. We are down here for 2 hours, right? Almost. It's not like 12 questions or something, but we are learning a lot. We are learning a lot jokes about. Okay, I think I will go and drink some milk, and after that I will come back and I will do 1.5 hour of stream. I hope